Have you ever seen a perfect sweet cherry and then poof, it literally explodes after a summer shower? Yeah, it's a real thing. And for farmers, it's terrifying. So today, let's get into the incredible high stakes science of exactly why cherries crack. And to really get a sense of just how high stakes this is, I want you to look at this number, $500,000. Yep, that's the potential value of just one premium cherry orchard right before harvest. I mean, imagine it. The sugars are perfect, the color is this deep, beautiful red. A massive payday is literally hours away. All that value just hanging there on the branch. But here's the crazy part. That entire fortune, it's unbelievably fragile. It's totally vulnerable to one of the most common things you can imagine. So what happens if it rains? Well, for a cherry grower, an overnight shower isn't a blessing. It can lead to what they call the cherry explosion. And when the sun comes up, the scene isn't a beautiful, refreshed crop, it's a total catastrophe. And the truly devastating part? It happens so fast. I mean, within hours, those perfect cherries get these deep, jagged cracks. The sweet juice starts oozing out, which of course attracts all sorts of rot-causing fungi. And just like that, a $500,000 crop turns into a worthless, fermented mess. So how in the world can a little bit of rain cause so much damage? This isn't some kind of magic. It's straight up biophysics. So let's crack the code of this catastrophe. Okay, so the whole problem really boils down to this one scientific principle: osmosis. No, don't worry, it's simpler than it sounds. Just think of it like this. Water always wants to create balance. It naturally moves from an area where it's pure to a place where it's full of other stuff, like, say, sugar, to try and even things out. And the cherry skin? That's the gate that lets it all happen. And this is where you get the perfect storm, in 4 simple steps. First, as the cherry ripens, it basically becomes this tiny, concentrated sugar bomb. Second, its skin, while it looks tough, is actually permeable. It has microscopic pores. So, step 3, when pure rainwater lands on that skin, osmosis just kicks into high gear. The water gets pulled inside to try and dilute all that sugar. The cherry just swells and swells and swells until, step 4, the pressure is just too much for the skin to handle, and pop, it splits right open. For a long time, people argued about this. Was it the rain landing on the cherry, or was it the trees sucking up too much water through its roots? Well, the data here pretty much settles that debate. The overwhelming majority of the problem, we're talking 80 to 90%, is from water being absorbed right through the skin. The roots, they play a tiny part. So the main takeaway is crystal clear. You have got to keep the fruit itself dry. So, knowing that, growers have come up with some really clever ways to fight back. These are the first lines of defense, and they're all about fortifying the cherry before a single drop of rain falls. They really use 2 main approaches. On one side, you've got the calcium strategy. Think of this like building internal armor for the cherry. They spray calcium right on the fruit, and it acts like a kind of cellular glue, making the cell walls stronger so they can resist that internal pressure. Then, on the other side, you have the biofilm strategy. This is like giving each and every cherry its own tiny, invisible raincoat. It's a spray-on coating that makes the skin water repellent, so the rain just beads up and rolls right off. Pretty smart, right? But sometimes sprays just aren't enough. When you have millions of dollars hanging on the trees, growers have to bring in the heavy artillery. And I mean, we're talking about massive, seriously expensive infrastructure. The ultimate solution really is this: retractable rain covers. I mean, look at this. These are basically giant, high-tech tents that can span entire orchards. They have sensors that detect the very first drops of rain, and then, boom, they automatically deployed this protective canopy. It's an incredible system, and it also protects against other stuff, like hail. Okay, but what if you don't have those covers, and a surprise storm just pops up out of nowhere? Well then, you make a call to bring in what growers call the giant blow dryer. And yeah, that giant blow dryer is a helicopter. I am not kidding. For over $1,000 an hour, pilots will fly super low over the trees, and then powerful downdraft from the rotors literally blows the water right off the cherries before osmosis can do its dirty work. It is an absolutely dramatic, incredibly expensive, last-ditch effort to save the crop. But see, all of these solutions, the sprays, the tents, the helicopters, they're all reactive. They're a defense. The real holy grail, the ultimate solution, is to solve the problem before it even begins, right at the genetic level. Scientists are literally trying to engineer the perfect crack-proof cherry. And this all comes down to breeding cherries for very specific traits. They're on a quest to create varieties with naturally more elastic skin. Think of it like a stronger balloon that can stretch more before it pops. They also want skin with fewer of those little microscopic pores that let water in. To test them, they literally dunk new cherry types in vats of water and time how long they last before they burst. And they're making progress. Varieties like Regina and Cordia are already showing much higher resistance. When you really think about it, it all comes down to this simple, powerful idea. For a cherry grower, the difference between a fortune and a complete failure is often just a couple of hours of rain. It's this high-stakes race against the clouds where everything can be lost in an instant. So the next time you bite into a perfect, sweet cherry, just think about all the incredible science, strategy, and maybe even a helicopter ride that went into getting it to you safe and sound from the rain.